Hello, Augies Worldwide. I'm Dave Kassler, amateur radio call sign KE0OG, here with another episode of Ask Dave. And today's is a shootout between multimeters. Now, I know I don't ordinarily do things like shootout, but other ham channels do, so I thought I'd try one. This is one between several meters. Now, let me show you what we've got. Now, before we look at the meters, let me pay a special thank you to James McDonough, a new patron. And thank you, James. You too can become a patron by going to patreon.com/KE0OG. Here are the meters. Here is the voltage source. We're just going to talk a little bit about each of the meters. I'm going to put a voltage source here of, let's bring it down to, 13.8 volts. Now, this is a power supply, Pivono, the PS105, which was sent to me for review a number of years ago. And I've used it as my bench power supply ever since. Now, it actually also works as a current supply. If I were to short these, it immediately goes into current supply mode, and it's supplying 5.26 amps, which will heat this stuff up pretty quickly. Okay, now, the first meter is one that I found in an old trailer. This meter right here is called a VOM for measuring volts, ohms, and milliamps. And it can measure either DC or AC volts. It uses a diode rectifier, so it's not going to be true RMS on the AC volts, but it measures in different scales. This goes up to 500 volts, so you can measure like the power supply on a tube type amp. We're going to come down here to 50 volts because the next one down is 10, and that's too few. Note that it will measure milliamps down here up to 250 and resistance up here. And again, there are different ranges. Now let's connect this to the leads. Okay. I keep forgetting that one's kind of weird. Okay, let's see if we can try to read this. There's a little mirror down here. So if we position ourselves over the top of it, the reflection in the mirror will indicate that you're exactly on. Now, if you go up here, there's 10 volts right there. Notice all the different scales you have to use. You got to know that you're using the right scale. This right here is 10 volts. Okay, and that would be 15 and 20. And this is looking like it's just under 14 volts. And that's about as close as you can get with the VOM. Okay, you can't read out the third precision. You get about 2 digits of precision with one of these. One of the other problems with this type of a meter is it does tend to load the circuit. By that I mean it's drawing current from the circuit, and it can affect your readings, especially if you are working with low resistance values and you're trying to measure voltage and low resistance values are involved. Okay, so this is the old trailer meter. Let's put this aside. Do I recommend buying one like this? No, absolutely not. Now, here is one that I do recommend buying. And actually, I just bought this for this video. This is a Harbor Freight digital multimeter. And let's look at what it measures, okay? This will measure DC volts, ohms, and it's got a range down here, and you have to set the range. So you start at the highest range, and then work down until you're within the range. 200 millivolts is 2 volts, okay? It's got AC volts, 200 and 250. It's not true RMS. And there is a little capacitance kind of thing, not really very good. DC amps from 200 microamps to 200 milliamps. there is a 5 amp DC value right here. Now this is separately fused inside, and you have to put the hot lead into here to measure those amps. And if you go over 5 amps, you're going to blow the fuse inside, which is a bit of a pain to change. Okay, HFE is, this is a transistor tester, which tests a little bit about transistors. Okay, and that's that one measurement you get. There are lots of measurements you can make for transistors. This is just one. This is continuity right here. So this will tell you if the leads are connected to each other. And yes, they are. Okay. And then we can measure ohms. Let's go up to 20 volts because we know that this is less than 20 volts. Okay. Now this, see here it measures 13.8. This measures 13.99 or 14. So it's 0.2 of a volt different from the meter. Now, notice how I said that. This right here is a meter also measuring this voltage. And there's nothing that says that this is particularly accurate. I mean, this is down in the 3rd digit, okay? And like I've said many, many times, the first 2 digits are often the important ones. So let's turn this off. These take a 9-volt battery. And 9-volt batteries are a pain to get. If you need one that's not too terribly expensive, run down to a dollar store or something like that. Okay, so this we can set aside. And now go to the next meter, which I just reviewed in a video. This right here has, you just turn it on. Hold that down to turn that on, okay. And it's auto. So this doesn't know what it's measuring, but it's going to decide, if you look at this, it put the little arm right here in front of the volts DC, 13.94. Okay, this is closer to this. This has some other capabilities on it. Including if you are doing continuity testing, you actually get a tone and a little green light, and then this measures the ohms itself. It'll give you the tone. Okay, so this also has a dial light on the front. If you push it like this, there is a dinky little flashlight on the back, which can be handy. Okay, and another thing that this can do is if you put it into this mode, non-contact measurements, we can take this out and hold it next to a, and see, this tells you that cord, which goes up to the light above, is hot. Okay, as it would do with all these down here, like those, okay? So this nice little meter for 10 bucks, all right, it'll go, and it will measure those basic things that I told you. Continuity, ohms. Note there's no amperage measurements on here. This can be a problem if you're trying to measure current for a project or something. The Harbor Freight will measure current up to 200 milliamps. It's a milliamp meter. This one right here does not, and then you just turn it off here, and it will shut itself off if you don't use it. One other thing I like about this meter is that it just takes 3 AAA batteries. 3 AAA batteries, if you buy them in bulk, are a whole lot cheaper than 9-volt batteries. Okay, let's put this over to the side here and talk about this one. Now we're in the $20 range. And this is a pin style meter. You connect the, now notice here, you can have a very small little probe if you want to get into the middle of a thicket and measure one particular voltage, whereas some, like the Tesman and the Harbor Freight, don't have covers like this. You can take that cover off if you want to, or put that back on depending on what you're going to do. I'm going to take it off so I can connect a clip lead to it. All right. Now the other lead, again, you can do the same thing up here on the top, small lead, big lead. We're going to need the big lead for, let's turn it on first. Okay. Auto. 13.92. So this is even closer. Now it does the same kinds of things in terms of detecting, let's see, does this detect voltage? I think it does. So let's take this off and go over here. Does it detect anything? Oh, you can change it to the volts that you want. Hertz, it measures frequency. Nanofarads measures capacitance. And live. Let's see if that'll give us anything. Doesn't seem to down here. Well, that doesn't work real well, does it? Now, PA is a phase. You first measured the A phase, and then you measured the B phase, and it will give you the phase difference in degrees, or I think in degrees, okay? So it's got lots of little things that it wants to do. There is a little tiny flashlight, again, here, and that's nice because it's right in the direction that you're trying to get a measurement, okay? So this is a $20 instrument. All right, and we'll turn that one off and put back the pieces so we don't lose them. Now this again has just, this is usually connected to the chassis of something you're working on or the ground of the unit. And then this right here is what you use. You can probe for voltages at the same time. You can see them right there and you know exactly what you're probing. That's a nice feature. Is it worth the extra 10 bucks? It may. If you do a lot of kit building and stuff, this would be very nice. Now let's take this one here, which is also a $20 Kaiwitz thing. And if you put it near, see, this will detect that there is AC voltage there, okay? And this is a plastic covered probe. So you can stick this in an electrical outlet and it will tell you if it's live, but you're not actually touching the electrical outlet. That's something very nice. Now let's go through our functions here. Here's auto, okay? So again, we can take the outside part, it goes over here. Okay, we'll put the negative on it, and we'll put the positive on this one. Okay, it's giving us 13.94, which is the same that the other one gave us. Okay, so as far as estimating the voltage that we're getting out of here, this one and the other Kaiwitz are about the same. Now, you can go through, I'm going to disconnect this. You can go through various functions. So you have kilohertz frequency, you have capacitance, connectivity or diode check, the live thing, and again the phase type thing, okay, and the non-contact measurement for the presence of voltage. So this has basically the same features as this other Kaiwitz. This has the ability to tell you what the measurement is as you're checking. And if you're doing a lot of kit building and stuff, this is very nice. Whereas if you use a regular meter, you're measuring here and looking over here for where the answer is. So this is $20. Would I recommend this? Yes, I would. Okay, so let's, oops, I want to keep the right leads with the right thing, and we've got both a red and a black cover to put on these. Okay. Now, this one right here is a very different meter. This is the Tech Power TP965 9605 BT auto ranging true RMS meter. And it has not only the test leads, which are on here, but there is a temperature probe right here. And there is a little thing that, being an optical thing on the back, you can connect this to your computer. And they even provide some software for it. Now, I don't know how good this software is. I don't really trust software that comes to me from China, actually, but and these little tiny things are often hard to read. And if it's 16-bit software, which it may very well be, it won't work on a modern Windows computer. So, okay, let's check this out. Now, this has a 9-volt battery in it, and if you don't turn it off, it takes too long for it to turn itself off. Oh, let's turn this on to voltage. Okay, it's auto ranging on voltage. Okay, 13.82, 13.81. This is a lot closer to this, and this is the highest quality meter of all of the meters that I've got right here. Now, as I give you a tour of this, there's a select up here. You can select AC, DC, back and forth between AC and DC, or you can just take the auto, okay? There are things you can do with hertz, duty cycle, a max and a min, a range, and so on. And this right here tells the system to talk over this to the computer, okay? So we've got auto for volts, millivolts, okay? This right here can be ohms, continuity, or continuity with the sound or capacitance, and you select which one you're going to do by pressing the select button. So it's really cramming a lot into that menu on there. Temperature, there's no temperature plug. Hertz, microamps, milliamps, and amps. And there's got to be a top. I wouldn't put more than 5. Oh, here it is right here, 10 amps. Okay, and off. Now, it says 6,000 counts. I have no idea what that means. Auto-ranging multimeter. Now, you run the amps in through over here, and for microamps and milliamps, you come in over here, and all other measurements are over here. Now, note you've got red, black. Everything else has black, red. So make sure you pay attention when you're using this meter. This meter was suggested by an Augie a number of years ago. I did buy it, and it's been my main bench meter ever since. So we'll say goodbye to our little Pinovo right here. And we'll talk a little bit about what we've seen. All right, let's talk about what we've seen here. We've taken meters from the cheap Harbor Freight. That little multimeter with an analog dial, I wouldn't bother with that. The Harbor Freight meter works just fine. For most amateur radio use, that Harbor Freight meter is going to be good enough for everything that you do. Now, if you do find yourself in a position where you need to measure true RMS, you'll do what I do and use an oscilloscope, because you're trying to measure something when you've got an odd waveform. You can look on the oscilloscope and estimate it better. By the way, I had a Fox Hunt hidden transmitter set up that was always off some degrees. Well, I couldn't figure out why from the voltmeters, everything okay, but I put it on the oscilloscope and found out it was 2/3 on one side, 1/3 on the other side. I tweaked it so that it was 50-50, and the thing continues to work just fine. So sometimes you want that oscilloscope. Now, what is an oscilloscope? It is fundamentally a voltmeter. And what you are looking at on the screen is the voltage, and it just goes up and down like any other. And this one has a bunch of numerical readouts, so it will tell you what it is reading in a variety of formats, okay? And you can connect it to the computer to monitor things for longer periods of time. The oscilloscope is something that you're going to want to aim for if you do a lot of kit building and stuff like that. Now, as far as the meters we've looked at, the Harbor Freight is good for almost all casual measuring. Like if you're trying to find a short or seeing if, a transformer is still good or something like that. It's great. Now, note, however, the safety issue. If you don't put, you got to keep your fingers back here, and this is pretty long. So if you're down inside of circuitry, I'd go with the Tesman, which measures a lot of things for $10, but why not pay the extra $10 and get one of these Kaiwitz meters? These are pretty neat. Or pay the $45 and get this big one right here. Again, it is the Tech Power TP9605BT, and they say only 15 left in stock, so order soon. But this is, let's see, sold by, I think it's stocked and sold by Amazon. Okay, nice little meter, but overkill for a lot of the stuff you do. Now, if you are even somewhat price insensitive, go for the more expensive meter. Okay, it has a lot of things it does better, and as we saw, it agreed with what the power supply said that we were putting out. It leads me to my final point that has to do with estimation. We don't know what the true voltage coming out of that power supply was. And we had the screen on the power supply estimated that it was putting out 13.8 volts. It doesn't know that, it just estimates that. Similarly, all these other meters are estimating the voltage. Which one is right? Well, actually, none of them. None of these meters gives you the exact voltage because you can't measure the voltage exactly. However, there's a trick in estimation. You could average all these readings, but one of the things you can do in estimation is give more credence to the more expensive meter. The way you would do that is multiply the first estimate by the cost of the first meter, the second estimate by the cost of that meter, and so on. Add all that up, and then divide by the total cost you put across those meters, and you will be waiting for the more expensive meters. Or you can just trust a meter you've had good luck with. Now, there is something called traceability on these meters. These meters, none of them are traceable. The National Bureau of Standards, which is now known as the National Institute of Standards and Technology, or NIST, which has an office in, I think, Gaithersburg, Maryland, and there's another one in Boulder, Colorado. They do set up voltage standards, and they have extremely accurate, meaning that their estimate is very, very good. Then you can have an instrument, it's going to be an expensive instrument, that is checked against the National Bureau of Standards. That's a first level measurement. And then that can act as a standard for other instruments. Now you've got second level, and they go to the third level, okay, for the expensive lab grade instruments. Otherwise, these are all just estimates. We're amateurs. We are not the professionals or engineers who need to make extremely accurate measurements with traceable supplies or anything like that. We do just fine with what's available to us as hobbyists, and you will too. So there you have it. If you would like to help support this channel, go to dcasler.com/support. There, that didn't take long, did it? And until we next meet, 73.